Okay, in a photoelectric effect experiment, a graph of the light frequency f is plotted against the maximum kinetic energy Kmax of the photoelectron as shown in figure below. Okay, so this is a graph of frequency against Kmax. Based on the graph, for the light frequency of 6 exponent 14 Hz, calculate the threshold frequency, the maximum kinetic energy of the photoelectron, and the maximum velocity of the photoelectron. Okay, good. So this is a graph of frequency versus Kmax. Yeah, frequency versus Kmax. However, the graph that we learn is Kmax versus frequency. Kmax versus frequency. This one is frequency versus Kmax. So it's a little bit different. Okay, it's like inverted. Okay, so how to solve the question? How to relate to the equation of photoelectric effect equation? How? So okay, so we need to rearrange this formula, okay, to suit this graph, frequency against Kmax. Okay, so okay, we need to rearrange the formula. It actually comes from this formula, E equal to Kmax plus work function, okay, which is where's the formula? Let me see. It comes from this equation. Okay, so let us write it down over here. Yeah, so E equal to Kmax plus work function. So this is the energy of incident photon. Okay, this is the energy of incident for the energy of the incident photon. This is the kinetic energy of the ejected photoelectron, and this is the work function of the metal surface. Yeah, work function of metal surface. So okay, this is energy of incident photon. So right here we have this frequency is the light frequency f. This one is the incident photon. Yeah, this light frequency is referred to the incident photon. Okay, this one also is the frequency of incident photon. Yeah, incident for the incident frequency of the incident photon. Okay, okay, so we need to rearrange the equations. Yeah, so energy of incident photon is also equal to hf, and then Kmax. Okay, just write down the Kmax over here, and then plus work function. Okay, we can change it to okay, never mind. Let us just maintain as work function. Okay. So you can see here, frequency is 1 over h. Okay. I divide this one. Both sides I divide. You know, I divide h. Okay. I divide h for all the symbol. Divide h. So this one, the h just gone. So this one divide h, Kmax divide h, I got 1 over h Kmax. And then this one is W naught divided by h, I got W naught over h. You see that? So here I have built an equation of what? I built an equation of y equal to mx plus c. So I can compare. Okay, I can compare. So I can see the y-axis is frequency, and then the x-axis is Kmax. X-axis is Kmax, and then the gradient of the graph is 1 over h. The gradient of the graph, what I can say is the gradient of this graph, should be 1 over h. 1 over h. And then what is this? This is the y-intercept. W naught over H is the y-intercept for this graph. So the y-intercept here. So this one is you know, the y-intercept. This one is W naught. What is actually W naught over H? Okay, maybe I can change it. Yeah, I should actually change the W naught into, we know that W naught is HF naught. W naught is HF naught or HC over lambda naught. Yeah. This one W naught, actually I can change the W naught into, W naught is actually HF naught. Whereas this energy of photon is E equal to HF. Okay. E is HF, W naught is HF naught. So E I have changed to HF. This W naught actually I should change to HF naught. Change it to HF naught. W naught is HF naught. F naught is the threshold frequency. So then this HF naught divided by H, I should get F naught. This one should be F naught. Can you see that? HF divided by H, I get F. K max divided by H, I get 1 over H for the gradient. Okay, and then HF naught divided by H, I get F. HF naught divided by H, I get F naught. So this is the y-intercept. So what I can say is I got the y-intercept here. This one is actually, what is this value? This value is F naught. The y-intercept here, this is the y-intercept. This one should be F naught. Understand? This one should be F naught. And then how about this value, -2? What about this value? This value happens when the frequency of incident photon is 0. What I can say is this value, it happens when this value over here, this happen when the frequency of incident photon is 0 Hertz. So that means I need to substitute this equation, the F, I need to substitute with 0. Then only I can get this value, -2. Okay. Okay, let's do it. Yeah. Let us investigate further. So based on this equation, okay, I need to highlight this equation first. Highlight this equation first. Okay, this is the equation for the graph. What I can say, this is the equation of the graph lah. Frequency is the y-axis, Kmax is the x-axis, this one is the gradient, and this one is the y-intercept. Okay, so this is how we rearrange the equation. Rearrange this equation, photoelectric effect equation, Einstein photoelectric effect equation. I rearrange to get the equation for this graph. Okay, I see this is the y-axis. Okay, this is the y-axis, this is the x-axis. So I take the F to the front and then X to the behind, and then I rearrange into the form of y equal to mx plus c, and then I can know what is the gradient, what is the y-intercept, and so on. Okay, so this is the graph equation. I can say this is the graph equation. Understand? This is the graph equation. Okay, so now I want to find this value. What is this -2 electron volt represent? What is this -2 electron volt represent? So that means this happens when the frequency of incident photon is 0. So that means I need to check over here. So I can put when the frequency is 0, that means when the y-axis is 0. So what is the Kmax? Okay, okay, I can say when y is 0, okay, 0 Hertz. Okay, now let's substitute. Yeah, let's substitute. Actually, that's the okay. So I use this equation. I substitute F with 0. Okay, and then 1 over H K max plus F naught. Okay, and this one is K max over H. Yeah, K max over H, K max over H, and then this one go to the other side, become negative F naught. Negative F naught. So K max is equal to negative. So this one H multiplied to the top become HF naught. HF naught. So what is this? What is this value? HF naught? Remember what is HF naught? Yeah, HF naught. HF naught is actually W naught. HF naught is actually W naught. So that means this K max value here is negative W naught. You understand? This one, this part. This is the W naught. Okay, HF naught. So this is actually HF naught is actually W naught. So what I can say is K max, I got the negative value, negative 2 electron volt. That means this 2 electron volt is actually the W naught. Understand? So this value is actually negative W naught over here. This is actually negative W naught for this one. Negative W naught. And pay attention to the unit here, and the exponent here. This is electron volt, not joule. He doesn't use joule, he uses electron volt. So this is 2 electron volt, not 2 joule. It's 2 electron volt. So you must pay attention to the unit. This is electron volt. And then this one got exponent 14. Exponent 14. So pay attention to this exponent also. Understand? So okay. So now we can do the question already. Now question A, he asked to find the threshold frequency. Should be easy. So question A, the threshold frequency is actually what? Is actually F naught. Want to find threshold frequency, F naught. So what is F naught? Okay, let's do it. So F naught is actually the y-intercept, but it doesn't give you any value for the y-intercept. So you cannot find the F naught from the y-intercept. You can find the F naught from the x-intercept, because the x-intercept is W naught. It give you the work function already. So from here, yeah, we can see negative W naught is actually negative 2. Yeah, negative W naught is actually negative 2 electron volt. Or we can just say that W naught is 2 electron volt lah. Okay, W naught is 2 electron volt. Now, okay, we how to find the F naught, the threshold frequency F naught? We need to use the equation W naught equal to HF naught. But the thing is, remember this one all must be in SI unit. All must be in SI unit. So you must change all to SI unit. The work done here, no, not the work done. This is the work function. This work function here, unit is in joule. Must be SI unit joule. So electron volt must change to joule first before you can substitute into W naught here. Understand? Why? Because the H here is joule second, unit joule second, and then frequency F naught here is per second. So you see that? So the right hand side over here is also in joule. Understand? HF naught here also joule. So this work function must be in joule. You cannot put electron volt. You cannot substitute 2 electron volt into here. Cannot. You must change this electron volt into joule first. Okay. So how to change it to joule? I just want to take back whatever we have learned before. How to change between electron volt and joule. Carry forward over here and do again. Understand? So how to convert between electron volt and joule? Electron volt, if you want to convert to joule, you multiply electron charge. Multiply electron charge. If you want to convert joule back to electron volt, you divide by electron charge. Understand? Okay, good. So what do we do now? Is this one we convert to joule first. Convert to joule first. That means multiply by electron. Multiply by electron, which is what electron charge is 1.6 exponent negative 19. Then you get joule. Understand? Multiply by electron charge. So what's the value here? Let's calculate. Actually, 2 times 1.6 is 3.2, isn't it? 3.2. Okay. So it is 3.2 exponent negative 19 joule. 1.6 exponent negative 19 multiply 2. You get 3.2 exponent negative 19. Okay. 3.2 exponent negative 19. So this you already convert the work function into joule. Oops. Yeah. Into joule. So now now only after your work function you got in unit SI unit joule, then only you can substitute into this equation. Okay. Because this work function must be in joule. Okay. Now let's substitute. This work function is 3.2 exponent negative 19 joule. Okay, and then what is the H value? What is the H value? Okay, so the H value you can find from the list of constant provided in the exam, list of constant value. So the H value is called the Planck's constant, yeah? Planck constant, which is 6.63 exponent negative 34 joule second. That's the H value, 6.63 exponent negative 34. Okay, so put it down, 6.63 exponent negative 34 joule second. Yeah, so yeah, that's the value. Yeah, 6.63 negative 34 yeah, joule second. So and then we can find the threshold frequency, yeah, as we want it. So what is the threshold frequency then? So this one, okay, 3.2 exponent negative 19, and then I divide by this value, 6.63 exponent negative 34. Okay, 6.63 exponent negative 34. So the threshold frequency is 4.83, yeah, 4.83 exponent 14 hertz. That's the threshold frequency. Okay, and that's the threshold frequency. I don't have the answer with me, but this is the value lah. Okay, this is the value, the threshold frequency. Now how about question B? What is the maximum okay, so what I can say is this value 4.83 exponent 14, you can write it over here. You can write over here this value, the y-intercept. The y-intercept here should be 4.83 exponent 14. Yeah, the exponent 14 already written at the top here. You see that? So yeah, this value here is actually 4.83. The y-intercept here. Yeah, the y-intercept here. Because I got the threshold frequency 4.83 exponent 14. So the exponent 14 no need to write because exponent 14 already in the label at the y-axis here. Label at the y-axis here. Exponent 14 already at the y-axis, exponent 14. So this one is just 4.83 lah. It's 4.83 exponent 14. Okay. So this is the y-intercept. I got it. Okay. Y-intercept. So now, okay, let's continue. Yeah, let's continue. How about question B? Question B asks to find the maximum kinetic energy of the photoelectron. So this is to find the Kmax. The Kmax, maximum kinetic energy. So how are we going to do this? I think just from the Einstein photoelectric equations, he give you, okay, he give you, you see, for the light frequency of 6 exponent 14, 6 exponent 14. So okay, so this is the frequency given. So this frequency is anywhere on the graph lah, somewhere 6 exponent 14 should be somewhere over here, yeah, should be over here, the frequency. So he give you the frequency. This is the incident photon, this is the frequency of the incident photon, frequency of the incident photon. Okay, now I can find the Kmax lah. I can find Kmax according to these equations. I want to find the Kmax. Okay, if I have the threshold frequency with me, or you want to use this also can, or you want to use this formula also can. Yeah, I think I use this equation lah, because I already derived this equation, isn't it? Actually, there are two choices. You want to use this equation, to find the Kmax, or you want to use this equation to find the Kmax, also can. If you use the first equation, then you use the work function value W0, which is 2 electron volt. But this work function electron volt, you need to change to joule lah, before you substitute into here. Yeah, you need to use the one with joule. Yeah, the 2 electron volt is over here. 2 electron volt is over here, but in unit joule. Okay, and then energy of photon, energy of incident photon, you calculate E equal to HF. Use the frequency here, then you calculate HF, then you can get the energy of incident photon, then you can get the maximum kinetic energy. Or the other way, you use this equation that you derived just now for the graph equation. This is the graph equation. You can also use this to find the Kmax. Understand? Because you already got your F0. Your F0 is 4.83 exponent 14, which is over here. I just substitute F0 over here. H is the Planck's constant, which is the 6.63 exponent negative 34. And then the frequency is the frequency of the incident photon. You also can get the Kmax. Okay, just use this graph equation lah, since we already derived. Yeah. So okay, let's do it. Question B. So we want to find Kmax. I just use this equation, F equal to 1 over F that you derived just now. Yeah. F equal to 1 over H Kmax plus F0. Okay, so this F you just put 6 exponent 14, 6 exponent 14 hertz, and then H is the Planck's constant. Planck's constant is Planck's constant is what? Planck's constant is the just now the constant value you got from list of constant, 6.63 negative 34. Okay, 6.63 negative 34. Okay, and then so Kmax, and then plus F0. What is F0? F0 is the threshold frequency, 4.83 exponent 14, 4.83 exponent 14, exponent 14. Okay, should be correct. So I can find my Kmax. So let's do it. Okay, 6 exponent 14, 6 exponent 14 plus this 4.83 exponent 14. Okay, and then I multiply. I multiply by this. Wait. This one go to the other side, should be minus. Okay, should be minus 6 exponent 14. Okay, 6 exponent 14 minus with this, minus with 4.83 exponent 14. Minus. Okay, after minus, I multiply by this 6.63. Minus already, I multiply by 6.63. Okay, multiply by 6.63 exponent negative 34. Okay, and I get the Kmax equal to, what's the Kmax? So the Kmax I got is 7.0 7.76 exponent negative 20. Exponent negative 20 joule in joule. Okay, that's the kinetic energy. I got it. Okay, the Kmax. I got the Kmax. Now, question C. I want to find the maximum velocity of the photoelectron. Maximum velocity. So I want to find the Vmax. Okay, I want to find the Vmax. Okay, maybe back to just now the question B. Let us check also, can we use this equation E equal to Kmax plus work function to get the Kmax? I'm curious. Let us also do the second way. Okay, question B just now. Let us use this equation E equal to Kmax plus work function. Yeah. Okay. So E is the energy of photon. HF. E is energy of incident photon. Okay, E is the energy of incident photon. And then H is 6.63 exponent negative 34. Okay, frequency of incident photon is 6 exponent 14. 6 exponent 14. 6 exponent 14. Okay, and then equal to Kmax plus work function. What's the work function? The work function I got just now. The work function is 2 electron volt. 2 electron volt. Okay, 2 electron volt. However, you cannot put electron volt here because the unit all in joule. Understand? The unit all in like this HF here is already unit in joule, isn't it? Joule. So the Kmax must be in joule. The work function also must be in joule. You cannot substitute electron volt into the equation. Cannot. Yeah. Yeah. This one you already got in joule. So all the rest must be in joule lah. Cannot be electron volt lah. So you cannot put let's say like 2 electron volt for W naught. Cannot. Cannot. So you must change the 2 electron volt into joule first. I already changed it. Which is 3.2 exponent negative 19 joule. That's the W naught. Okay, so W naught is 3.2 exponent negative 19. Okay, let's calculate. Let's put it over here. 3.2 exponent negative 19 joule. This one also unit joule. Okay, so now I can find the Kmax. So what's my Kmax? My Kmax is equal to, let's calculate, 6.63 exponent negative 34 multiplied by 6 exponent 14. Okay, and then minus 3.2 exponent negative 19. So my answer is 7.78. 7.78 exponent negative 20 joule. 7.78 exponent negative 20 joule. So is the answer correct? Yeah, almost the same, just differ a little bit. This one is 7.78, this one is 7.76. So what got differ? Because I round up the values somewhere. Yeah. So almost the same. So you still get back the same answer. You see that? So my answer here is correct lah. My answer here is correct. So there are two ways to get the answer for Kmax. Okay. So because this equation is the same as this equation. Understand? You just rearrange the equation so that it suit the graph. It becomes the graph equation. Y equal to mx plus c. Understand? So either equation, you still get back the same answer for Kmax. Okay, now I want to find the V maximum. Yeah, maximum velocity of photoelectron, Vmax. So Vmax I can get from Kmax. Understand? Vmax I get from Kmax, which is see the equation. Vmax I got from Kmax because Kmax is half m Vmax square. Or EVS, the stopping potential also get from Kmax. Stopping potential also get from Kmax. Okay, so Vmax I get from Kmax. Yeah. So okay, so let us do it. Yeah, let us do it. Question C. Okay, question C. Just now is OR. Okay, so Kmax is equal to half m Vmax square. And this is mass of electron because photoelectron are ejected. They are still electron. Yeah, they are still electron. Electron are ejected from metal surface. So use a mass of electron. Kmax, I already got the Kmax just now. And then I can find my Vmax. And then I can find my Vmax. Okay, I can find my Vmax. So let's substitute. So my Kmax is 7.76 exponent negative 20 joule. Okay, SI unit. Make sure all in SI unit. That the energy must be in joule, not electron volt. Yeah, must be in joule. Must be SI unit everything. Yeah. So okay, my mass of electron. Okay, where to get mass of electron? Can find from the list of constant. From the list of constant provided in the exam, you can find the electron mass. Electron mass is 9.11 exponent negative 31 kilogram. 9.11 negative 31. Okay, so that's the mass of electron, 9.11 exponent negative 31 kilogram SI unit. Okay. Use the kilogram. Don't use the atomic mass unit. This one is for later chapters. Yeah, use the SI unit, kilogram. And then Vmax. I can find my Vmax. Don't forget this one got square. Many students neglect the square. Okay, so let's calculate. 7.76 exponent negative 20. Okay, and then multiply 2, and then divide by this 9.11 exponent negative 31. Okay, and then this one you get what? You get Vmax. This one is Vmax square. The answer. And then you need to you need to square root. Don't forget to square root because got the square over here. Understand? You need to square root your answer. Students forget about the square root. So square root your answer, and the answer is, what's the answer? It is square root answer. I got 4.13 exponent 5, 4.13 exponent 5 meter per second. That's the answer. Okay, let me calculate again. 7.76 exponent negative 20 multiply 2. Okay, and then divide by this 9.11 exponent negative 31. Okay, and then I square root the answer. I get 4.13. Yeah, 4.13 exponent 5 meter per second. So that's the Vmax. Very easy. Okay, so that's the question for that's the answer for this question. So hope you understand the working. Yeah. Okay, so that's all for this question. All right, so hope you understand. Bye.